Welcome to another edition of RCE. Again, this is Brock Palin. You can find us online at rce-cast.com. You can find our old shows there, subscribe by RSS, iTunes, etc. You can also follow me on Twitter, where actually I've been kind of active recently, been mentioning some things, and we have a lot of upcoming events. So you can follow me on Twitter at Brock Palin, all one word. And again, I have Jeff Squires from Cisco Systems and one of the authors of OpenMPI. And Jeff, you just got back from another MPI forum meeting, so I assume the next revision of MPI is cooking along.
It's coming. There's a BOF at Supercomputing about MPI 3.0. We're looking to be done with MPI 3.0 by next Supercomputing, and that date is tentative, but that's the goal we're shooting for. And there's a bunch of interesting things coming in there, and the biggest fight right now is about C++, which is really interesting, and I feel responsible for because I created the C++ bindings back in 1996. But yes, anyway, the inner machinations of the MPI forum. But come to the BOF at Supercomputing to hear all about that. And speaking of BOFs, I have my own BOF as well with George Basilica from the University of Tennessee about the State of the Union for OpenMPI, and thankfully the supercomputing organizers did not put us opposite the MPI-CH BOF this year. Last year they did. It was kind of disappointing so you couldn't go to both, and I like to hear what those guys have to say too. So I think they're on Monday and we're on Tuesday, or they're on Tuesday and we're on Wednesday, or something like that.
Yeah, and I'll also be at SC. I'll be floating around. I'm not doing any speaking at SC, but I'll be there the entire week. Also, I have coming up at my home institution, University of Michigan, right here in Ann Arbor, we have a Cyber Infrastructure Days coming up. Just a couple of days, the 29th through the 1st, November and December. And I'll actually be speaking there on Exceed, which is the follow-on to TeraGrid with Phil Blood from Pittsburgh Supercomputing Center.
Cool.
I'll also be giving some other tutorials on compiler tips and stuff like that for the average researcher. So
yeah, I saw you advertised something about you did some MPI tutorial or something recently.
A very, very basic one. It's the one I asked if you wanted to come and do, but it's very basic. Then I found out they only gave me a 90 minutes to do it in. Like, really?
Yeah.
Okay.
Yeah. Not. I couldn't justify the travel for 90 minutes.
For 90 minutes, yeah, yeah. So yeah, I'll be speaking on that too, and the other random stuff focused towards people who are actually getting their hands dirty. So,
hey, and one throwback to supercomputing too. We feel like we need to mention the student cluster competition because that was just so awesome last year that we were a part of it, and the energy and the excitement around that. You need to go stop by and see all the students. I think they're on the floor this year or right adjacent. I'm not sure exactly where they are, but you need to go see them and talk to them because it was really, really very cool last year.
Yeah, no, that was a great thing last year, and I think Doug and those guys have been putting a lot of neat stuff together with teams and stuff this year. So I'm excited to see what. Actually, I need to look up what the challenges are this year, what the applications are. I'm curious.
All right, I'll throw out one last thing too. Also, my blog and my Twitter on there. Brock's been more active on Twitter than I have recently, but I've been answering a bunch of MPI related questions on my blog recently. So if you have any questions about how MPI works or why we do the things the way we do, or anything about the forum or the standard, please feel free to let me know, either an email or Twitter, and I'll write up a blog post about it. So with that, I think our pre-show extravaganza is done. Brock, you want to introduce our guest for today?
Yes. Our guest today comes from DreamHost. His name is Sage Weil, and he's actually I believe he actually started the Ceph distributed file system project. So, Sage, why don't you take a moment to introduce yourself?
Sure. Yeah, my name is Sage Weil. I did my graduate work at the University of California, Santa Cruz, where my thesis was on the distributed storage. And out of that grew the Ceph distributed file system. And since finishing, I've sort of continued working on that project to make it a viable open source solution to the scalability and reliability issues that people have for HPC type storage, and enterprise for that matter.
So Ceph basically built out of this work you did before. There wasn't encouragement from somebody else, or is this something you fully decided on your own you were going to go do?
It grew out of the Tri-Labs, the Sandia, Livermore, and Los Alamos, a series of grants they made to Santa Cruz to look at scalable petascale object-based storage system. And so there's some initial research there dealing with low-level object file systems and placement algorithms. But when I joined the project, I was focusing on distributed metadata and sort of how to deal with that issue. At the time, Livermore in particular was just starting to use Lustre, and they were having a lot of pain with lack of scalability in the metadata server, and so that was sort of a key motivation for that work. But sort of out of that whole, I know I started with metadata, but as a result, we sort of ended up building the rest of the system, including a scalable, reliable object storage layer and improved placement policy and so forth.
So what exactly is object storage as compared to, say, quote unquote normal storage?
I think traditional systems typically talk about storage in terms of blocks. So you'd have either on a single disk as block number, some large number, or in a SAN file system, you'd talk about block offsets within a LUN or something like that. In contrast, the idea with object-based storage is that you name, in the same way that you name a block by numbering it, you would name the object, but it isn't necessarily a number, and it doesn't have a fixed size. So the object can be small or large, and you can have some metadata associated with it as well. And essentially, the sort of the key idea is that while traditionally file systems have to pay attention to data layout and placement and block allocation and which sectors on the disk are storing what data, using an object-based interface lets you push all of that complexity into the lowest levels of the system where it's more or less hidden, and all the distributed, clustered, whatever, the higher levels of the file system don't really have to worry about those details, and it simplifies things greatly.
So does that mean Ceph, as much as it's a file system and a driver to be able to read and write to it, does it actually live on top of something else that actually deals with the actual 4K blocks going on disk? Exactly, yeah. So normally we put our Ceph OSDs, we call them, although it has nothing to do with this SCSI T10 OSDs. It's a sort of poor choice of name. But basically the Ceph storage servers that manage the objects sit on top of normally a Btrfs file system, and then where they actually show up is just files. And so the sort of the low-level file system on each of those nodes handles all those details. You can also run it on XFS or ext4 or whatever else, but that's the basic idea. And then Ceph itself only has to worry about what's in the objects and where in the cluster are they located. It doesn't have to care about rewriting a B-tree implementation to track free space or whatever.
Now, you threw out a bunch of alphabet soup there. Can you decrypt some of those things there? So you said things like T10 and whatnot. What are some of these things for people who aren't familiar with file systems and whatnot?
Well, I hesitate a little bit to talk about T10 because it's sort of a red herring. But essentially, there was a push maybe 5 or 10 years ago to have this idea of an object disk that basically encapsulates this idea of pushing the details of block allocation into the device. And the original vision was that you would actually buy a hard drive that you would store objects on, and the protocol, you wouldn't say store this block, this data in this fixed size block, but you'd actually name the objects and so forth. There's a spec that came out of that, and it never really took off. And so now when people talk about OSDs or object disks, usually that's what they think about, but in reality they don't actually exist in the real world for the most part. There are some people that sort of approximate that specification in their products, but nobody actually sells devices. So in contrast to that, Ceph is something completely different. So the idea is that you just take the basic idea of pushing the details of block allocation into the storage nodes and the lowest sort of layers of the system as possible. And then you can sort of focus on the hard problems of making it scale and distribute it and make it reliable and so forth.
So I think you already kind of answered this question a little bit, but let's get it explicitly. There's already a couple of free license parallel file systems out there, Lustre, PVFS2. Oh, why go in the complete direction of building a completely new implementation rather than just contributing distributed metadata to Lustre?
I think the real difference is that those systems aren't really designed with fault tolerance in mind. Whereas sort of when we were at the drawing board with Ceph, we sort of realized that in order to build something that's going to scale to hundreds or thousands of nodes or more, that you really have to design for failure from the beginning. And those systems tend to be constructed on